In this video, we're going to be taking a look at a 3-mass system where a 3 kilogram block that's sitting on top of a table is connected to 2 masses that are suspended off an edge. Now we are going to find the acceleration of the whole entire system, and we're also going to be considering friction as well. So before we get started, let's go ahead and draw the force diagram on each of these masses. Okay, so I went ahead and drew all of the forces acting on each of the masses, and we are also considering friction too, but we can't add in friction unless we know which way the block is sliding on the table, and we know that friction is going to oppose the slide going in the opposite direction. Now, if we have a 5 kilogram mass here, that is clearly more massive and heavy than a 2 kilogram block, so it's pretty safe to assume that the object, the 3 kilogram object, is going to be going to the right. Therefore, the force of kinetic friction will be going to the left. Now, the next thing we want to do is take a look at the system as a whole, and we could take a look at it like this. And kind of look at it as one big clump because it's going to be one large system that's mostly being affected by just a few different forces. So let's go ahead and take a look at the forces that we can ignore. Now, if we're taking a look at the system, any system that has internal forces can be ignored because the whole system isn't going to accelerate due to forces that are within it. So all of these forces of tension that are within it are not going to be affecting it. This normal force and this FG3 are equal and opposite to each other in the vertical direction. So those are in equilibrium. Those are not contributing to the forces that affect the entire system. So there's only 3 forces that we need to mainly focus on, which are these. The FG5 is going to be the main driving force of the entire system. And then we have the force of friction and the FG2 that are counteracting that FG5. So let's go ahead and set up a formula for those 3 forces and then set that equal to MA. All right, so there's our formula right there. We have Fg5 as our main driving force, and then we have Fg2 opposing that force because this mass over here is hanging off on the other end. And then we also have the force of friction from the table pushing back on our 3 kilogram block, and that's equal to the mass of the whole system. And then we are going to find the acceleration from there. So let's go ahead and plug in our numbers, and then we can go ahead and solve for that acceleration. So I went ahead and plugged in all my number values. We just had to use 2 different formulas basically, which is mg to find the force of gravity, the mass times 9.8, and we had to use mu times normal force. So mu sub k times the normal force gives us our force of friction. So our Fg5 is 5 times 9.8. The 2 kilogram mass is 2 times 9.8. And then for the force of friction, we have mu sub k, which I put second over here, 0.2, which was given in the initial part of the problem. And then for our normal force, that is equivalent to Fg3 because those 2 forces are equal and opposite to one another in the perpendicular direction to the table, or the vertical direction. So we took the 3 times 9.8 to find the Fg, which is equivalent to the Fn. So we took that Fn times 0.2. Now, once we combine all of these, that left us with 23.52 newtons as our total net force, and that's equal to m times a. Now, our m isn't just the 3 kilogram mass, even though that's sort of our main focus, but the whole entire system is moving. So therefore, the 5 plus 3 plus 2 is 10 kilograms in total. And then we divided both sides by 10 to finish off, and then we get 2.35 meters per second squared. That's the acceleration of each individual mass and the system as a whole because they're all connected to one another. So when you're solving a problem like this, you want to make sure you analyze the system individually and as a whole. And then mainly as a whole at the end, you're going to plug in your numbers to see what forces are driving the entire system and which ones are opposing it to find your acceleration. And be sure to include your total mass, the mass of all the objects connected in the system. So I hope that was helpful to you. Thank you for watching and listening.